Alright, so here is the second video. We left off at number 10. We're trying to find the inverse of each function. So there's some steps that we have to do to find the inverse. When you see f of x here, the first step is to write this in terms of y and then equals -5 plus 1/3 x. So after we replace f of x with y, we're going to interchange x and y. So now x is equal to, let me fix it. X is equal to -5 plus 1/3 y. And at this point, we need to solve for y. So I would add 5 on both sides of the equation. X plus 5 is equal to 1/3 y. And then at this point, to undo multiplying by 1/3, I'm going to multiply by 3 to get 3x plus 5 is equal to y. The last step is going to be replacing y with f inverse, or it looks like you're raising the function to a -1 of x is equal to 3x plus 5. For number 11, it's going to be the same thing. The first step is writing this in terms of y equals, I think that last one was in terms of x. Yeah, this one has n. I wouldn't take points off if you guys accidentally did the work in terms of x, but I'll try to keep it in terms of n for right now. N plus 2 to the 5th minus 3. After that, we interchange our input, which in this case is n, and the output y. So n equals y plus 2 to the 5th minus 3. Then I'm going to add 3 on both sides. N plus 3 is equal to y. Y plus 2 to the 5th. And now to undo raising something to the 5th power, I need to take the 5th root. So in the index, I should be writing a 5. The 5th root of y to the 5th is going to be just the y plus 2. So the 5th root of n plus 3 is equal to y plus 2. I now need to subtract 2 on both sides of the equation to get the 5th root of n plus 3 minus 2 is equal to y. Or as we were talking about before, the inverse of n, or the inverse of f of n is equal to the 5th root of n plus 3 minus 2. All right, for number 12, to state if the functions are inverses. I think a good way to think about this is imagining if instead of it was functions like f and the inverse, if it was directions. If you have directions to get from your house, right, somewhere and then to the store, then you should be able to follow those directions backwards to get home. In the inverse function idea of this, f of the inverse of f of x should just be equal to x. So you should be able to input this into the function and then get x. I'm going to show this with one of the easier examples we just did. If the inverse is 3x plus 5, and our original function is -5 plus 1/3 x, then I should be able to write f of the inverse of x. If we're doing this correctly, this should be equal to x. So f of the 3x plus 5, what would this be equal to? It would look like -5 plus 1/3. Oh, sorry. I'm realizing I forgot to make this 15. Sorry about that, guys. When we multiply both sides by this equation, it should be 3x plus 15. not just 3x plus 5. And so when we distribute the 1/3, this should be -5 plus x plus 5, or just x. So with this one here, because it was kind of complicated and it's difficult to show that it's the inverse or not, another route we could show, instead of trying to do f of the inverse of x, we could just find the inverse. Like if we're doing this correctly, when I find the inverse of f, I should be able to get g of x. So I'll repeat the steps I had from before. Y is equal to -1 over x plus 3. Interchange x and y. X is equal to -1 over y plus 3. So at this point, I would want to subtract 3 on both sides. X minus 3 is equal to -1 over y. To have y not in the denominator, I'm going to multiply both sides by y. So y times x minus 3 is going to be equal to -1. And I'm going to divide both sides by x minus 3. So y is equal to -1 over x minus 3, or the inverse of x is equal to -1 over x minus 3. So if you wanted to prove this by doing the composite function, like the f of g of, or f of the inverse of x, you could do that. You could also just actually find the inverse and see if you arrive at the same function they have here. In this case, these would not be inverse functions. On yesterday, we went over exponential functions. So for these functions, it's like f of x is equal to some base, and x is the exponent that changes. Some of the properties of these functions were that they're always going to have the y-intercept of 0, 1, because f of 0 is going to be equal to b to the 0, which any base raised to the 0 here that we're working with is going to be equal to 1. My advice was to make a table of values. I'm going to try to use graphs that are easier to see because these ones are kind of small. At 0, 1, 2, 3. And now for my y value, 2 to the 0 is going to be 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. We talked about it in class, but when this base is larger than 1, we're going to have this growth. If it's smaller than 1, I didn't use the word decay, but it's going to be shrinking. So as x increases, as we go up in x values, we should be seeing something that's getting larger, which tells me that b is not an option. All of these try to show us that they're starting at the point 0, 1, even though I don't think it's super obvious. It's hard to tell where the halfway mark is on here for like 1. So we could go by 2. And at 2, my y value should be 4. So here's 2. Looks like this one's 4. At 2, this is what looks like 9. And at 2, I think this is 16 over here. So my option would be A. Let me know if you have any questions. I think it won't be too bad with the number of questions we have for this. We're going to have one more class afterwards where we're going to be going over the review, and then we'll take the exam on the 11th. Again, email me if you have any questions, and good luck.